everyone, welcome to part 2 of the Math 32 Exam 1 on Chapters 1 and 2 review. So with this problem, I want to take a minute and sort of answer more than is just here. So this is asking me for the equation of this line shown below. So a lot of times, people will just say the answer is 0. But what is 0 for this equation? For this line. 0 is not the equation, 0 is the slope. So let's make a little chart here so that we can sort of organize this information so we stop getting confused. Okay, so if I have a horizontal line versus a vertical line. Okay, so of course a horizontal line is going to look like this, going from left to right. A vertical line is going to be up and down. Okay, so if I think about this, make a little table here. Okay, so there are two attributes that we care about. There are two things I might ask you about these sorts of lines. Okay, the first attribute is the slope, which we actually covered in questions 6 and 7, and the other one is the equation. Okay, so it is true that the slope of a horizontal line is 0. The slope of a horizontal line is 0, and the slope of a vertical line is undefined. Okay? However, the equations of horizontal lines or vertical lines are different. It's a different piece of information, right? Usually, in other cases, we would write an equation like this, y equals mx plus b, right? We know that the equations for horizontal and vertical lines look a little bit different, but there should still be an equal sign somewhere, right? And a variable somewhere. So you might recall that the equations of horizontal lines are y equal some constant, and the equation of vertical lines are x equals some constant. Now some people get confused because they're like, well, horizontal I usually associate that with the x-axis, and vertical lines I associate that with the y-axis. So that is true, and it's an astute observation. So let's see how we could maybe figure out how to remember this. So remember in class I talked about one way to figure out the equation of a vertical or horizontal line is just literally by going through this and labeling some ordered pairs. So let's just take a few points here, this one, this one, this one, and this one. Okay? So if I do that, let's just label these ordered pairs. All right, so this is the point -4, 2. This is the point -2, 2. This is the point 0, 2. And this is the point 2, 2. So if I stare at that, right, what pattern do you see emerging here? And the pattern that we see is that the y values are constant. The x values can be anything that they want to be, but the y values are always the same. Therefore, that leads us to the conclusion that y equals 2 is the equation of this line. Again, be careful. The equation of the line is not 0, right? The slope of the line is 0. But the equation is y equals 2. Okay. Likewise, if you were looking at something like this, where you had a vertical line, right? The slope of the equation of the vertical line is not undefined. The equation is x equals -2. So make sure when you're studying, you understand the difference between asking for the slope of a line and the equation of the line. Okay, so be careful with that. All right, let's look at number 10. In this case, we're asked to solve the system of equations by graphing. So this is the second and last problem for this test, where if you're doing this on your own paper, you will need to have a blank piece of graph paper. Okay, so make sure you have that handy. Again, if you don't have access to a printer or you can't get to the sorted by graph paper, please email me or come see me so I can help you. Okay, so let's start with the first equation, y equals -2/3 x plus 1. Okay, so we start with the y-intercept, which is 1. And now, since our slope is negative, I can go down 2 and over 3, down 2 and over 3, down 2 and over 3, down 2 and over 3. Okay? Remember what I said earlier, right? It doesn't matter where you park your car. So it could be -2 over 3, or it could be +2 over -3. So I want some points on the other side of that graph. To get that, I can go up 2 and left 3, up 2 and left 3, up 2 and left 3. Okay? And lastly, now that I've done that, I can connect all of these points with a straight line. Okay, so it's really important to note that if for some reason I had only drawn 2 points on this line, right, and tried to draw the line with a ruler, a lot of times you'll have what I call drift. And basically what happens with drift is that you start out touching, maybe these 2 points, and then, your ruler is kind of off, and then, it kind of ends up looking like that. And that's extremely problematic in solving systems of equations because we need the exact ordered pair where these 2 lines meet. And we can really only get that when we are very precise about our graphs, which means we need to plot as many points as we can using the slope. You need to completely fill the page, fill the graph paper with points. Okay, let's graph the other guy. So 2x plus 1. So already we're at 1, so we kind of found the point of intersection anyways. But to get full credit, we also need to finish graphing this line. So remember, our slope is 2 over 1. Okay, so that's positive 2 over positive 1. It's also equal to negative 2 over negative 1. So I can go down and left, down and left, down and left, down and left. Okay, and then last but not least, I can connect those points with a straight line. Okay, let me erase this. It's pretty ugly here. So this says that positive 2 over positive 1 equals negative 2 over negative 1. Okay, and of course we have our point of intersection here. It's right here. Okay, and this is the ordered pair 0. Oh, sorry. Yeah, that's right. 0, 1. Okay, so to get full credit for this problem, 1, you have to have a complete graph. Right? You need to show your work. You need to plot many points, just like I did, not just 2. Okay, and then you need to write your solution as an ordered pair, just like we did. Okay, so again, if you want full credit for this problem, that's what we need to see. Okay, I guess you could also write x equals 0 and y equals 1. That's also true. I think it's just faster and easier to just label the ordered pair. All right, let's do number 11. So in this problem, it's kind of interesting. We are allowed to do either substitution or elimination. We'll get credit for either one as long as we are able to identify which method we are using. So since you might pick one or the other, I'm going to show you both. So let's start doing this problem using the substitution method. So substitution means the first thing I have to do is isolate one variable. I'm going to choose to isolate the x because it's almost all by itself. All I have to do is add y to both sides of the equation in order to successfully isolate the x. So this gives me the equation x is equal to 10 plus y, or y plus 10. Now that I've done that, I'm going to use the other equation, 3x plus 2y equals negative 32. And I'm going to take this expression, 10 plus y, and I'm going to substitute it in place of x. So I'm going to write 10 plus y here, and I'm going to fill in the equation around it. Okay, so negative 3 times 10 is negative 30. Negative 3 times y is minus 3, or negative 3y. Then we have 2 plus 2y equals negative 32. Okay, I'm going to bring down my negative 30. I'm going to combine like terms. That gives me minus 1y, or just minus y. And then we get equals negative 32. So obviously I'm out of room up here, or over there. So I'm going to write negative 30 minus 1y equals negative 32. Oops, sorry. Negative 32. Okay, I have all my variables on one side. So what I would like to do is I would like to get my numbers on the other side, and I'm going to do that by adding 30 to both sides. Okay, so bring down the minus 1y, and that gives me minus 2. If I divide both sides by negative 1, we find out that y equals positive 2. Okay, at this point, it might feel like, gee golly, I really should be done. However, we're not done. There's 2 things left to do. One thing that is left to do is I need to find the other variable. So if y equals 2, then I have x minus 2 is equal to 10. And by adding 2 to both sides of the equation, we see that our x value is equal to 12. Okay, you might also recall in other classes I really encouraged you to check your work using the other equation. So I'm going to try to do that in the little space I carved out for myself over here. Okay, so I just used this equation. I cannot use it again. I have to use negative 3x plus 2y equals negative 32. Okay, so I'm going to put 12 in place of x. I'm going to put 2 in place of y. And we're going to see if this is, in fact, mathematically correct. That's a 2. Okay, so negative 3 times 12 is negative 36. 2 times 2 is 4. And in fact, it does check out. Negative 32 is equal to negative 32. So that is correct. So now we're going to do the exact same thing. However, we're going to use elimination instead of substitution. So again, remember on the test, you're getting points for correctly identifying which method you've chosen. You can use either method, but you have to say, if you're using substitution, you have to make a note and say, hey, I use substitution. If you decide to use elimination, you have to make a note and say, hey, I used elimination. So there's probably lots of different ways to do this. My choice is going to be to eliminate the y values by multiplying the first equation by 2. Again, as long as you get the same answers. If you, for example, maybe decided to multiply the first equation by 3 so that your x's canceled out, that is also a valid approach. So remember, as we do higher level math, we can see that there are often many valid approaches or ways of solving. So this gives me minus 1x equals what? Minus 12. Divide by negative 1, divide by negative 1. We get x equals 12. Cool. So then I go back to this other equation, x minus y equals 10. So I have 12 minus y equals 10. What should we do now? I guess we should subtract 12 from both sides. And we get negative y, don't forget your negative, equals negative 2. Right? You can make that a negative 1y. Divide by negative 1, you get y equals 2. Okay, so I don't really need to check this since, right, I just did the problem here, and I got the same answers, didn't I? I got x equals 12 and y equals 2. So I know from, since I did it both ways, I can tell that it's right. But again, I'm assuming that on the test, you would just be doing, one or the other method. So you would also, depending on what method you use, you would still want to be checking your work. Okay. So we have negative 3 times 12 plus 2 times 2 equals negative 32. Again, I just did this on the other page, but I'll write it out anyways. So you get negative 32 equals negative 32, and we're done. Okay, so I think there's only one more problem, and of course that's a word problem. So remember, for the test, you're not going to be asked to solve. All you have to do is fill in the table and write your equations. Okay, so they already identified the variables for us. It says x is the number of children's tickets sold. So I'm going to put x here for the number of children's tickets sold. I'm going to put y for adult tickets sold. Okay, and then we have a total of 1,000 people attending the concert, I guess technically. Should talk about ticket sales, because I guess you could have bought a ticket and not shown up to the concert, but we're going to assume that 1,000 is the number of tickets sold. Okay, then the price of tickets. The children's tickets are $20, and the adult tickets are $30. Okay, we could add these, but that doesn't really get us any closer to a solution. Remember, to get the third column, we always multiply across. 20x, 30y, and then, right, the total amount of sales, right, from our tickets was 18,800. So here we have our 1, 2 equations. So we're going to have x plus y is 1,000, and then we're going to have 20x plus 30y equals 18,800, right? And that's it. We're done. That's all you need to do for this problem.